Well, welcome to Emerald Hill Skies. We are happy tonight that you've joined us. My name is Doug, and I'm coming to you from the outskirts of Louisville, Kentucky, here at Emerald Hills, where we have an observatory. Let's see if I can bring that up, let you see that observatory. It's a Pure Tech Telestation 2, and we've got a RASA 11 there you can see peeking out of the top. And of course, these images were taken during daytime, so you could see what's kind of in the observatory. But at nighttime, it's a lot darker out there. We'll show you a picture in a second. You can see the height adjustable pier that RASA 11 is perched on top of. And in the background, you can see a monitor we can use when we're working there in the observatory to tune up the scope, maybe adjust the back focus or tilt or whatever. It's a roll-off roof observatory, meaning that the entire roof is rolled off. Let's see if we can get you a live view of the scope. That image that you see right now is live, and you can see we still have quite a few of those rain clouds that have been plaguing us all day long. Those rain clouds are there. I'm just going to check and make sure our audio is coming through. Yeah, great. Those rain clouds that have been coming through. Dennis, good evening. Sorry about the winds in Colorado tonight. I hope those subside so you can get your scope out later. Anyway, as you can see, we still got those clouds that are kind of plaguing us, but we've had really solid rain for the last 3 days. And the forecast tonight was for extremely clear skies. So I have to believe that these are breaking up, and maybe if you study that image, you can see that those clouds are moving at a pretty good clip. So as long as there are clear skies behind them, we'll be happy, won't we? Let's take a look at the sky through our ZWO ASI2600MC mono camera that's sitting on top of the scope in a kind of an outrigger configuration. In fact, you can see it here in this picture. The red camera thing that you see there in the upper left-hand corner of each of these shots, that's the ASI2600MC mono camera. And you can see it's not focused through the telescope itself. It's actually just sitting on top of the scope. And we have that lens that gives you about a 150-degree view of the sky, pretty much like the human eye, in fact. And so when you look through this image, you're actually seeing that view through that 178, and this is live. We're not. This is not some kind of video recording. While we're there, I might mention we are really loving that Pegasus-Astro Pocket Power Box Micro, and we're looking right now. The temperature is a balmy 47.7 degrees. And the relative humidity is 99%. So you can see that the rain and the fog are still kind of hugging us, but hopefully our little dew zapper that's built into the Pegasus Powerbox Micro, that's going to give that dew, I hope, a run for its money. We're watching the current that's flowing through the dew zapper coils right now. It looks like about 2.8 amps. Somewhere around there. Shouldn't be any problem to keep that dew off, we hope. So that's the little blue box that you see sitting on top of that outrigger. By the way, right underneath that Pegasus Pocket Box Micro power connector distribution box is a Pegasus Astro USB controller. And the USB controller distributes all kinds of signal to it brings in signal and distributes signal so that we're able to get you these live images, and those are riding on top of that RASA scope, kind of like this. In this picture that you see, the white, of course, the white tube is the 11-inch RASA, and the ASI mono camera that you see, the 178, is on top there with that Pegasus Astro gear on a Los Mandi equipment plate, kind of like an outrigger, kind of hanging around up there on top the telescope. Now you might be interested in this RASA telescope because you can see the black tube that's fastened to the front of the RASA. That's one of those, what is it called? Astro Zap. I forget the name of the dew shield that's out there in front. Inside that dew shield is this red camera that you see mounted to the front of the RASA corrector plate. And that camera is a ZWO ASI2600MC Pro. That 2600 ASI-MC Pro is a full color, one-shot color cooled astro camera. It's an astro specific, an astronomy specific camera. You can see a couple of cables connected to it. One is for the data, and the other, of course, is for the power that helps that camera be able to power its built-in cooling engine. And you can see how there's a little glass corrector plate that red camera is mounted to there. And that glass plate is called the corrector plate. When the light first enters the RASA, that corrector plate makes a little bit of a shift in it so that it can be able to direct the light in the right lanes, so that when it hits the objective mirror at the end of the RASA, then it will be well focused to be able to come back up and connect to the camera. So right now we've just finished an autofocus run. I gotta be honest, our autofocus run did not behave like it usually does. We've been trying to use the new Hocus Focus plugin in Nina, and tonight the Hocus Focus plugin didn't behave as it had been, and so it's obvious that some of my settings are not quite right. I'm gonna have to listen a little bit closer to that Patriot Astro video, thank you Chad, and adjust those settings a little bit more precisely. So I went back and reverted to the Nina autofocus. We'll see how well that did in a second. Right now we'll bring up that camera and just see if we can connect to that camera. I'm going to switch back to the full screen view so you can see pretty much what I'm seeing here. We'll make this sharp cap screen a little bit bigger so we can see a little bit more what the camera is seeing there. And I guess that's not bad. I don't really like the job it did on the focus though. I think we can improve on that focus, and I'm really sorry to say, as we start out tonight, usually that Nina autofocus would have done a better job. By the way, Jeff, I'm sorry to hear you've had wind in Montana too. My goodness, 50 miles an hour. That's a lot of wind, but we really appreciate you checking in tonight, Jeff. I know you've had a long day in the operating suite today, and it means a lot that you would stop by to check in on things. As you can see, our autofocus has not gone as well. So what I'm going to do is I'm just going to zoom in at 100%, and I'm going to try, if I can, to I guess, I've not done this for a long time, but I'm going to try to see if I can connect to this focuser and see if we can do a little bit better job. It's right now sitting on 30,029. So I'm going to try 30,100, and you guys all please watch with me, and we'll see if those donuts get bigger or smaller. So this is kind of like being at the eye doctor. I think they got a little bit smaller, didn't they? So we'll try 30,200, and we'll hope to see those donuts getting, oh, they did. They got more pinpoint, didn't they? I'll try 30,300, and then what we're trying to do is see, did those pinpoint stars get even more pinpoint, or did they get bigger? Oh, I think they're more pinpoint. I tell you what, that's not bad, is it? Right here, we've got a nice pointed star. I'm just going to touch my screen and make sure that's not a bit of lint on my screen, and I don't think it is. I think those are pretty nice pinpoints for 100% zoom. You can see we've still got some clouds moving through the picture there. See all that mist that's combing through the picture. I think we're just going to leave the focus where it is for right now. And sooner or later, though, I've got to work on that focus. Maybe after the broadcast tonight, I'll do some work on that focus and see if we can't improve that a little bit. Up here in the upper right, we've got this Pocket Power Box Micro. I'm just going to move it down here a little bit so it's kind of out of the way of our list, because here in our planetarium software, which we use Starry Night Pro, you can see that we're pointed toward the north. Now what we're going to try to do now is actually connect to the scope. So we're going to do the telescope control and say connect and see if it connects okay. It's always like a drum roll because you know that old phrase we all use in electronically assisted astronomy, what could possibly go wrong? Etienne, it's nice to have you on from Mont-Tremblant in Quebec. It's good to have you here. Etienne, thanks for joining us. It did look like we're connected and we're tracking, so I'm going to drop that little telescope control screen. And sure enough, if we zoom in now on the little field of view indicator, you can see that there is this little crosshair, and it's right on that meridian, indicating that we are polar aligned, and that shows us where the crosshairs are located. Now what we've tuned up here tonight is a list of the Caldwell objects. And I'll tell you what, while the clouds are still disappearing, let's just take a look back at the sky cam again. You can see those clouds are still clearing. We're seeing a lot of breakup of those clouds, thankfully, and we're hoping they'll be gone in a minute. But while those are clearing, I just want to say a word about the Caldwell List. Now, everybody knows about the Messier list. In fact, last week, a group of, I don't know, a couple of dozen of us got together and we actually tried to run through all 110 objects in one night in this big marathon. And different time zones of astronomers were passing the baton to the next astronomer in the next time zone. And we kind of ran through essentially most of the time zones of the world, from New Zealand and Australia all the way across to places like Switzerland and Spain and UK, across the ocean into North America and the Midwest and the rim of the Pacific in Pacific time zone. And in all those time zones, we actually, by God's grace, managed to get through all 110 objects barely. It was really touch and go on the first object of the night and the last object. But I'm happy to tell you we did get M74 and M30, ran through all 110 objects of the Messier list. So the Messier list is a great list, and it actually, as you recall, was sort of invented or first cataloged by an astronomer in 1760s named Charles Messier. And he was a French astronomer. He was on top of a hotel in Paris, and he didn't have a telescope that we would have like today. This was a very primitive homemade equivalent to a 3 or 4 inch telescope. Bright city lights of Paris even back then. And really, to be honest, he wasn't a deep sky observer at all. He was a comet hunter. And the objects that he kept running into were these fuzzy little splotches that he finally concluded were just staying in the same spot in the sky, so they weren't comets. And he didn't know what they were always. He called them, nebulae or whatever. But he started listing them in order that he wouldn't sort of waste his time on them again. And he would distribute this list to his other buddies who were also comet hunters with him. So you can imagine a guy who made a list of what not to look at. Really, this was just trying to make a list of the things that looked most like comets that would distract him in the night sky. Fuzzy splotches that looked like tailless comets. And he didn't really approach them in any kind of order. It was basically more or less the order that they were discovered, either by Charles Messier himself or by his assistant or some of the other astronomers that were feeding him information. First he listed, a few dozen and then more, and finally got up to, 90 something, and down through the years, other researchers that have combed through his logs have found evidence of several other objects that he discovered or chronicled, but maybe didn't publish. Now we're up to 110 objects that are a part of the Messier list. They do happen to be some of the best objects. Let's don't disrespect Charles Messier too much, because in trying to find the objects that he didn't want to look at, he actually assembled a pretty decent catalog of some of the greatest starter objects for all of us in astronomy. And we still enjoy going to some of these objects today, and objects you've heard of like the Pleiades, M45, and the Great Nebula in Orion, M42, and this list goes on and on. Some of the most beautiful objects of the nighttime sky he managed to list. but he missed several of them because maybe they didn't look like comets or because they weren't visible in his night sky at the northern latitude where he observed. So along came a guy called Sir Patrick Moore. In the 1990s, he was an amateur astronomer. He decided that it was unfortunate that several of the objects that Messier listed should really also be in an amateur astronomer's bag of objects, in the list of objects that we should be looking at. So he started making his own list. Now, he couldn't really name them after his last name, the Moore list, because then he knew they'd be abbreviated M, and M was already taken because of Messier. But it happened that his last name was a compound name, and he usually had dropped off the first name when he signed documents, I guess short documents, but if he signed official documents, he would always put his entire compound name. And you've already guessed it, his entire compound name was Sir Patrick Caldwell Moore. So he called this list the Caldwell List, and it stuck. And it's abbreviated in many astronomers' books and websites. It's abbreviated with a C. So you'll see C1, and that has nothing to do with middle C on a piano or low C or whatever that would be, C2, C3, C4, and so on. Those are the objects of the Caldwell List. And I've got here a book by Stephen James O'Meara. It's one of the best books, I think, on the Caldwell List, the Caldwell Catalogue of Deep Space Objects. And it basically goes through the list one at a time in the order that Sir Patrick Caldwell Moore, listed the catalog. He decided he would be more intentional about his listing method. Rather than just the order that he discovered them or took a notion to name them, he listed them in order, for the most part, from the most northern object to the most southern object. So, object number 1, Caldwell 1, you can pretty much guess that it will be the northernmost object in the sky. And as you progress through his list, also 110 objects, he kind of wanted to be a companion to the Messier list. By the time you get to the upper parts of his list in 80s, 90s, 100s, and so on, it's really far in the southern hemisphere. So when we get to that part of the list, we're going to recruit some of our Australian and New Zealanders to come alongside of us and let us see live that part of the list. In fact, I was messaging with one of them today, and he actually said he was going to be on with us tonight until clouds snuck into his sky and made it impossible for him to be able to do any kind of observing or imaging, visualizing with us tonight. Otherwise, we would have had a southern astronomer, and we could have taken turns and done one from the north, one from the south. That's the great part about the Caldwell List, is that it covers objects in both hemispheres and doesn't maybe cheat those that are down in the southern part of the sky. So here in Starry Night Pro, I don't know what your planetarium program is like. As you probably know, if you watch Emerald Hills Skies, you know that we've been using Starry Night Pro for several months now, but maybe you use Stellarium or Sky Safari or the Sky or whatever you use, and I would never disrespect any of those. But in your planetarium program, if you can look up the Caldwell List and see it listed as C1, C2, C3, maybe it's listed in that order. To be honest, in Starry Night Pro, we import our observing lists from a public server that SimCur makes available. It's called Live Sky. And, I'm sorry to say that on Live Sky, there was no Caldwell List at all. So I had to actually hand enter all the objects using their NGC number. And in Stephen James O'Meara's book and the Caldwell List, it's real handy because the NGC number is there every time. And also you can look up the objects then by their NGC number. And so what I've done is I've entered them here in the Caldwell List in Starry Night Pro so that we'll have them to work from. And then what I did is I made a copy of that list, and I called that new list Caldwell Working List. And maybe the fine print is too small. You might have to try to enlarge the screen. But I've put that list here in the observing target list in Starry Night Pro over toward the right here. And then the next thing I did is I sorted them by the altitude they are in the night sky. And we want to try to get as high as we can, because otherwise, if you're too low, you're looking through more atmosphere. And on one of these humid nights when there's a lot of moisture in the air, you can bet that your views will be very, very poor, what we call in astronomy seeing. The seeing will be poor. So we try to look at the objects very high. So we're going to see these objects listed by their NGC number, but this is the Caldwell list, mind you. And when we go to the information about that object, we'll be able to see what number it is on the Caldwell list. And remember, we're going through by altitude, not north to south. So they won't always be in the order of 1 through 110, like you might have hoped or expected for us to go through the Caldwell list. What we'll do is we'll look them up, we'll look at the information, see what it's about, and then on the working list we'll copy them over to another list we have, which is called Caldwell Observed. And we'll put them on the observed list, and that way we'll know that we've gone and looked at them, and then we'll remove them from the working list. And it won't affect my permanent list, because I'm working with a clone of that permanent list. I've still got the Caldwell list going, but this is the Caldwell working list. We'll remove them from the Caldwell working list, move them over to the observed list, and remove them, and then we'll be able to move on to the next object. So if you haven't already guessed, I've kind of been introducing all this because I thought, well, this is a good time to introduce things since everything is kind of cloudy still. So I'm looking down, I'm looking at Scott. It looks like Scott C once again is up in cloud-covered Niagara. Scott, we have the same problem here. There's Michael C. We have a lot of Michaels in our EAA group, it seems like. So this is Michael C. Good to see you again, Michael, and it looks like yours are clearing there. So that's very good news. Michael is filling us in that 52 of these objects are in the northern hemisphere and 58 are in the southern hemisphere. So now we know exactly how many Caldwell objects there are in the north and south. Now, not all of those will be available on any one night, but it usually takes us maybe 3 to 5 minutes to look at each object. So in an hour, we can usually only see 12 objects at the most, and that's if everything goes well. In 2 hours, we might see 24. So we'll be just fine tonight, okay? So let's go ahead now and get started. Let's look at this first object, and what I'm going to do is I'm going to mark it. I'm going to center on it so that we can see exactly where it is. Let me make sure you're back at the screen. Here we go. I'm going to center on it, and you're going to see there. You're going to see the planetarium software move in, and here you'll see our scope, because the next thing we're going to do is we're going to slew, and slew, of course, is a name that means move. So in that screen there, you'll actually see the telescope start to slew over to this direction in the nighttime sky. It was pointing due north. We've got our camera in slightly different position tonight. We've finally gotten it snaked through the conduit under the observatory floor. So it's no longer, this scope cam is no longer laying along the floor of the observatory. And I'm happy to tell you that, because I was constantly afraid I would trip over it. So there you see the telescope aiming over in the east. Let's go back to our entire screen view now, and we'll kind of back off of this view so you can kind of see the cardinal points. Here's east and there's south. So we're looking due southeast. You can see we're in the constellation Leo. For just a second, I'm going to put the other constellations up on the screen so you can get oriented. This is the Big Dipper, and that'll kind of give you a little bit of orientation. You know, these two pointer stars at the end of the bowl point toward the North Star, and if you just go the other direction, then you go in the direction of Leo. So the opposite direction of the North Star from those two pointer stars, the Big Dipper's bowl, and we'll see the constellation Leo. And inside of Leo's head, that's where NGC 3626 is. Now, it's kind of a mystery. We're going to open up the information pane, and we're going to see that this is C40. So what you could do is you could make a list on a piece of paper, kind of number it 1 to 110. If you're going to follow us during these, nights that we're going through the Caldwell list, you could make a list 1 through 110, and you can put a check mark or a scratch off beside C40. Now you can see that we actually observed this object back last year on April 15th, and we were looking at non-Messier objects just for fun, and we wrote here, we were glad-hearted that in the midst of all life's uncertainties, NGC 3626 was still up there waiting to be observed. That's kind of fun. I think that was in the middle of COVID, don't you think? Sounds like I was in that kind of mood, doesn't it? Right now, we're gonna start a new observation. So we're gonna hang here, and sure enough, it's picked up for us that we're looking at the Caldwell list. I wonder if you can see that. I'm gonna move this just a little bit higher so you can kind of see what I'm looking at. It's picked up that we're looking at the Caldwell list, and we're gonna associate this with the Caldwell working list. A Caldwell working list here. And then we're also going to check here and make sure that we've entered the telescope that we're using, which is the RASA 11 with the 2600. Now once we put those on, I hope they'll stay. I think they'll stay for the rest of the night. So we'll just say here, super cloudy, but still peering through. Still sneaking some views through the mist, something like that. Okay, so we should be staring at Caldwell 40 now, NGC 3626, and let's kind of zoom in. This is a spiral galaxy. It's fairly small, isn't it? I mean, look how small it is. This is going to be a really small target in a RASA 11. Let's see if we can see somewhere. Boy, not a lot of description there for this object, is it? See if it tells the angular size. It doesn't. So we're going to have to go look it up. Let's go to our actual view through the RASA 11, and let's put here C40. And let's also go down to the title. And I'm trying to remember here, C40, which is NGC 3626, a spiral galaxy. And wow, not a lot we're seeing there in our view. There's so many clouds. Let's go to our sky view. Yeah, look at that messy sky. So we're just going to catch, now and then we're going to catch views. There won't be a lot there to stack, will there? Jeff, yeah, pretty cloudy there, Doug. Jeff says, that's exactly right. We're going to trust that sooner or later we're going to get to do some, tell you what we're going to do. We're going to try to sneak in a plate solve here real quick. And we're going to see if our equipment can take a picture of the night sky between these clouds and these stars and get a match to the database of stars that it has stored in its memory, connecting with our software. And if it's, and it was able to find its location in the night sky, and it's moving it about 2.77 degrees, which is pretty typical of the first target. Remember, we don't do a 2 or 3 star alignment. The pier is indeed, it is indeed polar aligned on that pier that you see inside of the observatory. That is a Pier Tech adjustable height pier. So the scope is, the mount is polar aligned, but we don't do any kind of star alignment with the actual mount and scope when we turn it on. So let's go ahead and start live stacking and see what happens. We're going to actually switch to our live stacking sequence, and we'll go ahead and I'm sure it'll clear out the live stack, and it's going to take probably 20-second exposures in between these clouds, and we're going to see how it does in this weird night. It's taking these at 100 gain, And we're just going to see in a minute when this first image comes up, we're going to see what it looked like. Oh, not bad, right? So let's bring our dark adjustment line in histogram over to this peak, and let's bring our mids over just a bit. Let's do a color balance so that we get a little bit better color balance. That's looking pretty good, and we should be, Lord willing, right on that galaxy, Caldwell 40, and sure enough, right there in the middle, you can see a fuzzy patch, and that patch is going to be coming in little by little. It's going to come more into focus. I'm going to zoom in now using digital zoom, and you'll start to see some of the haziness around this inner core that we see glowing there, and that haziness is in fact the structure of the galaxy. We'll zoom back out to 100 and let that stack for a minute. While that's stacking, here's what I'd like to do if we could. I'd like to see if we go to, let's find, remind me what the, Jeff, I love being able to see two different views of your sky. You're very kind. Remind me, what is the Hubble address? It's like nasa.gov. Let's say NASA Hubble, let's just do a search, NASA Hubble Caldwell List, and see if we can find that list. Yeah, it's nasa.gov, and the slash happens to be slash content. What I'm going to do is I'm going to move this up into our screen, and while that's stacking for a second, I'm going to make this a little bit bigger. See, where can I put this so it, I guess it doesn't have to be that big because NASA has their page restricted. And we're going to try to go to images here. No, that didn't work. We're going to try to go to, here we go, Caldwell 40. Let's click on Caldwell 40 and let's see Caldwell 40 the way Hubble saw it. This was taken at the Max Planck Institute for Extraterrestrial Physics using the Hubble telescope. And you can see the inner core really bright, and then you can see these outer rings, spiral arms that are filled with star-forming material. You can see that there's another view of Caldwell 40. It was discovered by William Herschel in 1784. It's 70 million light years from Earth and has apparent a magnitude of 10.6. It also says it's one of the smallest Caldwell objects in the sky, so you need a larger telescope, and it's best to do it on a night when there's no moon. So there you can see the location in Leo. That's where we were a while ago. So you can kind of see this is what we're looking for. Now let's go back to our live view. So here we are back to our live view. We're going to zoom in a little bit more, and we do have 12 stacked frames and 0 have been ignored. But I'll tell you what, we're using SharpCap, and SharpCap is extremely good in spite of occasional problems with images. It's extremely good at finding the locations of these other stars and lining up frames with them. So we have 4 minutes of information, and I tell you what, this, let's see if we can doctor this up a little bit. Let's move this black. Let's do one more color balance, and let's pull this black over a little bit. Maybe we can make this a little bit better. Maybe to about right there. And then let's move the mids in. We're going to give up some detail here and look at some modeling, MOTT, some grain in the sky, just so we can start seeing some of the material around the outer part of the galaxy. Now I'm really using a lot of optical zoom here because we're at like 160% of I'm sorry, digital zoom, what I meant to say, well, I'm using a lot of digital zoom. That's the extent of our optical zoom. So this tells us that this is one of the smallest objects on the Caldwell list. And I think it's a good object for us to start with. And Jeff says he's following along on this page. That's awesome, Jeff. So I think what we've done is we've succeeded in kind of getting our workflow down pat. I am going to go ahead and snap a picture of this because I think that's, important for the sake of observing. I'm going to go back over here to our observation, and we're going to click back into the same observation and say, wow. Well, I think I am. Sometimes on our first object, what we end up having to do is deleting it and restarting it. And I have spoken to the guys at Simcur about this. And they said, yeah, we're not going to be able to fix that right away. So this is a known bug. Anyway, I'm going to say, wow, this has to be and is one of the smallest objects in the entire Caldwell list. We could make out the core and some of the structure through the mist, but honestly, not much. I'm going to be honest here about our observations, gang. I'm not going to cheat too much. So there you go. Now I just do want to remind you, this is an approximate field of view of our RASA frame. So even on the best of nights, look how small this target would have been. I mean, think about it. There's not a lot of structure visible in the planetarium software. And when we go over here to the real live image, not a lot either, but just you can see a hint of the nebulosity. You can see why this object didn't trouble Charles Messier too much. So what we do now is we go back over here to our list and we say, add this to Caldwell observed. And then what we'll do is we'll go back to our web page, and we're going to open up a copy of our livesky.com webpage. And from now on, we'll keep this open, so we won't have to open it up each time. But in Live Sky, this is a quick place where you can go, fairly quick, you can go to your observing lists, and you can click into Caldwell Working, and you can do a search for C40, and it won't find it because it's got it cataloged as NGC 3626. And right there it is. And what we're going to do is edit. Now we have to search for it again. I forgot about that. 3626. And we're going to remove, I'm going to make sure we're in Caldwell Working, and we are. We're going to remove NGC 3626, Caldwell 40, from the working list. So that way it's gone, and we know that we've observed it because it's on the observing list. It takes it a while to sync, so it won't disappear immediately here in Starry Night Pro, but it'll disappear eventually. Now let's center on the next object, and we're going to center on it. We're going to go back here to our actual live view in SharpCap. We're going to stop live stacking. We're going to do that by using our sequencer and say next target, and that'll stop live stacking. We're going to go back over to our planetarium software where we're slewing over, and we're going to take a look at our scope as it slews into position. Here's our sky. Well, I think it's beginning to clear somewhat, but it's still quite a bit of clouds over in the east, but you can see from the west, the left side, in other words, a lot of nice black clear sky coming in from the west. Thank the Lord. Back on our screen, we're going to zoom out to see where we are. And again, we're here closer to the Big Dipper now. A while ago we were in Leo up here. Now we've scooted over here to the little constellation. Looks like we're in Canis Venatici. And we're going to zoom in, and oh, this is a beautiful little object here. Look at that. NGC 4244. We're going to open up some info on it, and we'll put that info right here so it's out of our way. And it is C26. So we're going to go over to, first we're going to slew to this now. We're going to slew to NGC 4244. Here's our scope cam. You can see it repositioning there so we can aim at 4244, and you can see how the sky cam kind of glides along with it as it moves. So it looks like the scope is in position. We've got clearer skies now, don't we? A lot clearer view there. That's our sky cam. And then let's go back over to the screen cam, and let's zoom in a little bit so we can see what this looks like. And wow, that's going to be a neat object. Let's put in C26 here, and we'll also go to our sequencer and say, well, you know what I want to do first? Before we actually begin stacking, let's do another plate solve. And that'll help the scope put in another element of correction into the model. And with each element of correction, we become more and more accurate through the night. Remember the last time we went, we had to correct 2.77 degrees. Well, this time we only had to correct 0.05 of a degree. So with each correction, the mount gets a little more accurate. And I'm just so thankful that God's given us a good mount. This is the iOptron Sim70G. And it really is a nice mount now that we've figured out how to use it. And the trick is, don't put your USB 3 data through the middle of the mount. You gotta do that with your wire hanging off the back. So if you look very closely in the scope cam, there's a little wire, water falling off the back of the scope. That is primarily that USB 3 cable. Once we stop sending USB 3 signals through the mount, life was good. Okay, so back here to our screen again, we're going to put in C26 as our object title, and we're also going to go down to our title that we use now for the I'm going to say C26, and this is also a spiral galaxy. It's NGC 4244, a spiral galaxy. And then we'll go back to our screen cam, and that is definitely not NGC 4244. What in the world happened? We lost connection to our camera, didn't we? That's just the weirdest thing ever. Okay, so we're back to our camera. Let's go to our sequencer, and let's start imaging. Well, let's see here. C26, we must not have tabbed out of that. We're going to sequence back here, start imaging, and it'll start live stacking on that. And while that's doing that, let's read our last entry. We did look at Caldwell 26 before on March 2nd, 2021. And when we did, we said edge on spiral. Awesome. So we're back again tonight. We'll start a new observation of this. And you see it kept our list that we're working on, the Caldwell list. It didn't keep the associated list, and it didn't keep the equipment. I'm not going to fool with putting those in there each time. That's just too much. So we'll say here, super foggy night. And this is what we're looking for. We're looking for an object that looks like, how would you describe this? Spiral galaxy in Canes-Vanatici, located 15 million light years from the sun. It's edge on. It appears as a long, thin, bright streak in a telescope. And let's see if it gives us any other information. 16 arc minutes. So we'll have to go to our Hubble page now. Let's go back over to our Hubble page, and we're looking for C26. So we're going to hit the back button, I think. I'm going to go down here and say C26. And there is a nice close-up of this, not to be confused with the Needle Galaxy, Caldwell 38. Caldwell 26 is often called the Silver Needle Galaxy. So the Silver Needle is a spiral galaxy that spans about 65,000 light years across. It lies over 13 million light years from Earth toward the Canes-Vanatici constellation. It's a member of the M94 group, which is a small collection of galaxies that is a part of the same galactic supercluster as the Milky Way. Yep, Dennis has already mentioned it there, the Silver Needle Galaxy. And you can see where it's located in relationship to Ursa Major, the Big Dipper, and line it up like with Polaris. You can see where it's located. So this is a neat Hubble image. Roloff de Jong took this. The arms are not visible since we're looking at it edge on instead of face on, but you can see that diminutive central bulge, and you can study that halo. It was discovered by Herschel in 1787. Herschel was a busy guy. Cataloged as 4244, NGC 4244. NGC stands for the New General Catalog. It's not so new anymore, huh? It's over 100 years old now. It's about magnitude 10.4 in larger telescopes. It'll be difficult even in small telescopes. So let's go back over and see how our live image is stacking up. Let's, I think our color stack is okay. Looks like we might have started stacking just a little bit too early, but let's go ahead and roll with it. So we'll put our blacks there. Let's do a color balance just the same. Ah, look at that needle starting to form up there. We'll put this black level about there, and we'll start pushing our mids down and see if we can't bring out this Silver Needle Galaxy a little bit better. I think we're going to have to go into 100% again. And sure enough, you can start seeing it form up there. Now, do you notice we must have started with the first frame a little bit early? So let's just, since we've only been imaging 3 minutes, let's clear this and start over and see if we can't get a little bit better view of this, because I think we were a little bit jumping the gun and started our live stacking before our mount had finished its syncing with the night sky. So yeah, I think this will be a little better. Let's do one more. Actually, our color stack doesn't look bad, does it? You can start seeing the Silver Needle Galaxy form up there from the beginning. And while that's stacking up, I'll just say a word about the Caldwell List. Sir Patrick Moore was quite a radio personality. In fact, I will see if I can find a picture of him. He, oh, here's a nice picture. Let me see if I can get this up in the webcam so you can see Sir Patrick. Here's Sir Patrick. I don't know, there you go. He was a very distinguished looking guy, and I happened to be able to track down a video interview with him, and it was neat because the video that I tracked down was the video when he first introduced the Caldwell List to his radio and video listening audience. This was in June of 2000. Not that long ago, really, 22 years ago. I think he died in 2012, somewhere around there, passed away. But in the year 2000, he was still doing this BBC kind of sky at night broadcast. And as he told the audience about this, and for the first time clued them in on the Caldwell List, it's kind of neat because he was making history. People were, for the first time, beginning to pick up on his Caldwell List that he had invented, he had coined. He actually had sent that list to the magazine Sky and Telescope. Even though he was a UK observer, he had sent the list to the American magazine Sky and Telescope, and they had printed it. And by the time the year 2000 came, a lot of people were enjoying his list because they were ready to go on to something beyond the Messier list. And these objects are a little bit more challenging, but nevertheless, they're still beautiful. So let's zoom in a little bit more. We've been imaging for about 2 minutes. And already in 2 minutes, you can see, I hope you can see that, quite a bit of this Silver Needle Galaxy. They're already forming up. I'm going to push those mids up a little bit more so we can try to brighten this up for you. I think you can probably already make out that inner core, the bulge that's there. I hope. Well, if I put it on screen, you ought to be able to. You can already make out that inner core, where all those stars are so close together, relatively speaking, that from our observing position, it just looks like a bright inner core. Now, imagine if you were one of the planets revolving around one of those stars in the middle of this Silver Needle galaxy. You would see all these stars lighting up your night sky. It would be a beautiful sight for sure. We're at about 218% in heavy digital zoom here, but you can still make out this edge-on galaxy in that middle core. So I think we'll just put that in our observation. In spite of the humidity, what was the humidity? Do you remember? I think it was very high. Let's see what it was again. Well, all this stuff is in the way of it. Here we go. 99% relative humidity. So in spite of the high humidity and correspondingly poor seeing, we could still make out the inner core and the edge-on beauty of this, the Silver Needle galaxy. Now you might be noticing that the picture image just changed. I believe that's because we've had a cloud pass by, and when we did, you see how it destroyed SharpCap's ability to follow all those stars. So I think we're going to go ahead and stop stacking, because this image is not going to be as much of a keeper, is it? Sad to say, it's not going to be as much of a keeper. But we did, I think, we were successful in being able to make out at least the general view of the image of C26. Okay, so now we're back. We've stopped live stacking, and we're going to go over here to our. We'll close that observation out, and we're going to once again we're going to say add to the observed list. Then we're going to go back to our live sky page, and at live sky we're going to search for 4244 and delete that from the working list. I'm just checking to make sure we're indeed deleting it from the working list, and we save that just so it's nice and saved. And now we'll go back to the next object, which is NGC 4449. And the first thing we'll do is center on it. And let's go on and slew to it. And we'll put you in scope view so you can watch the scope slew to it. Looks like we're not that far away from the last object. This again is, let's bring up the information. This is C21. C21, and we did observe it before. Let's go back over here and put C21 in SharpCap. I'm going to put you back on the screen. C21, we'll tab out of that square so it saves it this time. And then in the title, we're going to say C21. This is an irregular galaxy. So it's C21 or NGC 4449, an irregular galaxy. And then we'll go back to the screen. And why don't we do one more plate solve? We don't need to do a plate solve, do we? This is going to be in the middle of our frame, isn't it? Do we have faith? Yes, we have faith. So let's just go straight to start imaging. And it'll clear out the last live stack of the Silver Needle. You can see the sequence is finished. Once again, like I said, it starts exposing at 20 seconds. And we can see we have several folks taking part tonight. We've already heard from, I guess, Dennis and Jeff, Etienne, Scott, Michael. If you haven't logged on yet, feel free to let us know your observing location, the place where you live, and also maybe say something about if you've observed the Caldwell List before, or if these objects are new to you, you could maybe say something about that. I'm going to make this just a little bit blacker. And also, let's start out with our mids just a little bit lower. And you can already see that irregular galaxy forming up there in the middle of this frame. We're going to let that stack just 2 or 3 more frames. And while it is, let's go back to our planetarium software, if we can. And let's zoom in. And you can see this is what we should be looking like. Let's see where we are in the sky. Once again, we're getting closer to the Big Dipper. We're right in between the Big Dipper and Canis Venatici. Oh, rats, we're seeing clouds move through again. Rats, rats, rats. Well, let's go ahead and zoom in here while we can. That is definitely an irregular galaxy, and sure enough, our mount is beginning to move. That's just a bummer when those clouds move through. Just spent some time with C38 last outing. Nice. Hello from Northern Rivers, Australia. Rowan, welcome to the live stream. I don't think we've met you before, Rowan. We're glad to have you aboard. You're from Northern Rivers. I'm going to have to go look that up. Boy, I just hate it. You know what else I wish SharpCap had? We talked about this during the Messier Marathon. Wish we could reject the last image, the last one that just got messed up. But we can't. So I'm going to start the live stack over again. And while we do, let's go over to the Hubble image. And let's see what Hubble found when it, see if it got through the clouds in its location about 350 miles above the surface of the Earth. Not as many clouds up there. Let's try to go to this object, which is C21. So again, we'll go down the page and we'll click to C21. And wow, Hubble's image is fairly mixed up. Now, you remember the way the Hubble telescope is set up? I think, if I remember right, there are like, are there 8 different, I forget how this works, 8 different cameras maybe that work as one, but the camera that's up here in this corner has a, I forget, a higher resolution or something. So this corner of these Hubble images are always missing. I don't know if you've ever, it's always missing. That's just a, it's just a fact of the Hubble Space Telescope. But this is the galaxy we're looking at. It's an irregular galaxy. Now, irregular galaxies, as you know, are mixed up. And it says here in the fine print that, I wonder if I can make that bigger for you. Let me see how I would do that. I don't dare, wonder how I can make that bigger. Can I, see, I can't just, I wonder if I go Control plus. Does that make that bigger? If, or is it Shift plus? There we go. It says that the spiral feature in the upper portion may resemble the arm, but it's actually a small portion of Caldwell 20 in GC 7000, the North American nebula. And we're not looking really at Caldwell 20, are we? We're looking at Caldwell 21. So let's go down the page. Oh, I must have clicked on the wrong image. Let me go back down to 100% and go backward. I must have accidentally clicked on Caldwell 20. We want to be on Caldwell 21. Oh, they don't appear to have this cataloged correctly. Well, that's a bummer. I'm going to open up a new, move this tab over to here. I'm going to open up a new tab. I'm going to say Hubble Space Telescope Caldwell 21 and see if we can find that page. Okay, we had to go at it a different way, but I think we found it. This is Caldwell 21, and you can see this is just a random, weird-looking thing. It's 10 million light years from Earth. It's star speckled because of all the stars that are being born inside of this galaxy. The dusty pink areas are those star-forming regions. And because this galaxy is relatively close, and I guess you gotta use the word relatively when you talk about 10 million light years, we can see stars forming. Now the blue-white areas and stars, those are the brand new, young, massive stars. And these are giant, high temperature. You know, our sun is like, a medium temperature star, like yellowish, whitish, yellowish, you know. But these blue stars are giant, and they're going to burn really fast. And they will end their lives by blowing up, and maybe even in a supernova someday. So this is Hubble's advanced camera for surveys. And again, this camera sees things through mosaic that stitches together objects like this. This Caldwell 21 is 20,000 light years across. And that seems like a very wide space, doesn't it? It takes light 20,000 years to travel from one side to the other. But when you stop and think about it, it's just 1/5 of our own Milky Way galaxy, which is a pretty medium-sized, if not a little bit larger than medium-sized galaxy. This was discovered in 1788 by, you guessed it, William Herschel. It's magnitude 9.6. You can spot it in a telescope, and in a large telescope, it's a rewarding object with a complex pattern of bright knots. Okay, so let's go back to our live image. Oh, my goodness, we've got some live knots here. Now, this is 50% beyond the optical zoom. So we are well into the digital zoom, and we are well into a bunch of clouds, unfortunately. And I'm just sorry about those clouds streaming by, kind of ruining our views. But in spite of that, look at these bright stars that we can see in star-forming regions. And even though things are stained with the misty clouds we have tonight, I think you'll agree this is still a beautiful, if random, kind of image. So over here we're going to do an observe. Let's look at our observation, Irregular Galaxy. And I just wrote the word peculiar. That was on March the 6th, 2021. So let's do a new log entry, and we'll say we saw a little better detail of this irregular galaxy, including some of the brightest blue-white stars. The giants, or the ones burning, let's say the ones burning brightest and fastest. Unfortunately, clouds continued to plague us. Okay, so that's C21. And we're going to go here in our list, and we're going to say add to Caldwell observed. We're going to go back to our live sky list, and we're going to search for 4449 and delete it and save it. Okay, we're going to go back to, we're not going to save that. We're going to stop live stacking and go to our next target. Michael C. says, Auckland. Oh, Michael, you're that Michael. Welcome, Michael C. Regular view. You regularly view the Caldwell. Approximately 20 of them never set from your location. Many are visible with binoculars or the naked eye from a dark side. So much easier than these faint galaxies. Nice. Rowan, we're so glad you're here. we prayed last year that God would raise up some people from the south to join our team because there were objects we were not seeing well, and we just also wanted somebody from New Zealand or Australia. And you are the answer to our prayers, Rowan and Michael. And Michael, we're going to get you back when you have clear skies so that we can ping pong back and forth and do a southern object and a northern object, and a southern object and a northern object. But we'll get you when we have clear skies. Let's take a look at our own skies. Wow, they're starting to clear better and better. Look, we're being photobombed by a satellite or an airplane. That might be an airplane flying through Hum. One or the other. Let's go back to our screen. And let's see, we're done with C21. Let's look at our next object here, which is 2419. And we'll center it. And as it centers in our planetarium software, you can kind of get an idea of where it is in the night sky. So we're going past the Big Dipper, past Lynx, and right there you can see it's a globular cluster already marked there for us. So now we'll slew to it, and we'll show you the scope cam. And while it's slewing, we'll also open up the info pane. It's C25. So this is C25. So in our sharp cap, we'll put C25. And in our title, look how far the scope is. We're changing sides of our pier. C25. C25. And we'll go to our title and we'll say C25. Oh my goodness, this is Intergalactic Wanderer. Oh my goodness, that sounds so mysterious. Globular cluster. The Intergalactic Wanderer. Wow, that sounds like something right out of Star Trek, doesn't it? Now, I'm not liking our focus as much now. Are you? I don't like this as much. Oh, we're at 154. Let's go back to 100. Oh, that's better. Okay, so it's just that we were in our what you might call digital zoom. The 8-hour time difference might make for a very slow game of ping pong. That's good. Good, Michael C. All right, since we did appear a meridian flip, let's go ahead and do a plate solve while we're here. While that's plate solving, let's go back to the sky cam. Oh, I'm loving this. Look how the clouds are breaking up exactly as forecast. There still are quite a few clouds up there, though, and they can skate by at any time and ruin our view in sharp cap, can't they? We were 0.48 degrees off after that meridian flip. So you can see we're correcting now. We're correcting. And we're going to make sure that our scope has settled all the way before that looks pretty good actually. So let's switch our sequence now to start imaging. And while that's imaging, by the way, let's go back out to auto here. While that's imaging, let's go back to our planetarium software and let's zoom in on this. So we're between, again, for orientation, we're between Lynx and Gemini. Oh, I can already see that globular cluster. I don't know if you can see it here on the left. It's just so tiny there. Let's take a look at that while we can. Let's do a color balance of this part of the sky because this is a part of the sky where the light pollution is fairly strong. Let's go into 100% right off the bat. And yes, sadly, our light pollution is fairly strong here, but get a few more images of that. And while that's forming there, let's zoom in on it. Look how tiny of a globular cluster this is. This is roughly our RASA field of view. It almost looks like just another star. I mean, this is Hipparchus 37133. These are not particularly notable, giant stars that have proper nouns. But look how, even so, this object is smaller than its neighboring stars. So that's a bummer. But if we zoom in very, very tight, you can start to see that this is a neat little tight globular cluster there. Now we're at 10 minutes wide for our field of view. 10 minutes. Let's go over here in the description. NGC 2419 is a globular cluster. Globular clusters are densely packed balls of stars from 50,000 to 2 million stars are bound together in a sphere with a radius of no more than 100 light years. All the Milky Way globular clusters are ancient, up to 15 billion years old in their apparent age, the age that they look to us. At least 149 globular clusters in the Milky Way have been discovered, and more than 100 are in the NGC-IC Catalogue. Their distribution forms a spherical halo centered on the core of our Milky Way. So what that means is these globular clusters are not just flat in the disk, revolving around the center of our night sky. Instead, they're like a buzzing swarm of bees all around the night sky. We're going to zoom in a little bit closer here. And let's play with first let's do another color balance, and let's move this dark adjustment line right about there, and then push these mids up. This is a very faint cluster night, but part of that is these clouds that are skating by are ruining our image. It's confusing our sharp cap. It almost makes me want to do tracking tonight. Wouldn't that be fun to start doing tracking? I wonder if we had tracking, we would have less. What's your guys' experience? Rowan, haha, Michael, so true. We can always email our staked or final images to Doug. Stacked. Gotcha. Good idea. There, the color balance shifted a huge amount when that cloud image went by. This is just the best we're going to get. I think we're going to be able to see the structure of this globular cluster, but not a lot of the stars. So for that, let's go back over to Hubble, and let's see. This was where we went, and no, this was the one where we should be able to hit the back button, and we want to go to Caldwell 25. C25. Oh, show off, Hubble. Oh my goodness. Now this is where you really would wish that you have the Hubble in your observing view. Look at this beautiful Hubble image. Caldwell 25 is unusual. Unlike most globular clusters, which are huge spherical clouds of old stars, believed to be among the oldest in the galaxy, Caldwell 25 may not be from our galaxy at all. It's located about 300,000 light years from Earth. The cluster is sometimes called the intergalactic wanderer because it is so far away, even farther from the Milky Way, farther than the Milky Way's largest satellite galaxies, the Small and Large Magellanic Clouds, which Michael and Rowan have been able to observe, I'm sure, many times. And they're 160,000 light years away. Scientists have surmised that this cluster may be part of the remains of a small galaxy that was captured and disrupted by the Milky Way. It seems to be fairly similar to other large globular clusters, but its extreme distance makes it difficult to study and compare its properties with other globular clusters in the Milky Way. This interesting cluster hosts two distinct sets of red giant stars that have different amounts of certain elements. Red giants, you recall, are the stars that result when a medium mass star, like our star, expends its fuel and keeps burning during most of its lifetime. One of Caldwell 25's red giant subsets, found mainly in the central region of the cluster, has a surprisingly high amount of helium. And the differences between the two groups has led scientists to question whether maybe there are two stellar populations here which merged. Caldwell 25 was discovered by, take a guess, William Herschel on New Year's Eve in 1788, while everybody else was out there with those noisemakers and, the all those things, and they were singing Auld Lang Syne or whatever that song is and kissing their honeys. While all that was going on, William Herschel had buried his eyes in an eyepiece and had just discovered Caldwell 25. And we are the better for it. Has a magnitude of 10.4 and it's considered in the constellation Lynx. In a typical amateur scope, it just looks like a soft, hazy, circular miniature glow. And the stars are not usually resolved. On a clear winter night, you can spot it with maybe binoculars or maybe even the naked eye, but no, not the naked eye, with binoculars. Now, we have had these clouds move by our image a lot. Looking down to see if anybody's ever done tracking on a night with clouds, and I wonder if that helps us. I very rarely have to do tracking because, our images are normally 20 seconds long and I just do 4 to 6 minutes of integration. But tonight, I'm beginning to wonder. There's the live image. It is a mess because of those clouds confusing our scope. So we're not going to save this either. We're just going to C25. We're going to go back to next target. And over here in our, we did an observation in February. Super close to the moon, but it's a beautiful cluster, I said. I think I was being a little optimistic there. Let's add a log entry and let's say, wow, this tiny glob looked just like a tiny glob. On top of that, clouds kept disrupting the live stacking process. Still, let's leave it at that. So that's NGC 2419, otherwise known as Caldwell 25. So we'll close this. We'll put NGC 2419 in the observed Caldwell. And then we'll go erase 2419 from the live sky. We're going to search for 2419, delete, and save. Okay. Back here in SharpCap now, we'll go past it to our planetarium software and let's center on NGC 4631. Why does that sound familiar? And we'll also slew there and let you go to scope view. So as we take a look, you can see that we're slewing back across the meridian. And that usually doesn't scare us. We're going over toward where we were before. And we're right beside Canis Venatici again. And 4631 looks like another needle. You can see the scope slewing over there. You have the G on the Sim 70. You can always use it right. Exactly, Jeff. And I did try it once, and I think I have the lens cap off. Let's just look at it. Let's see if I have the lens cap off. We're going to open up PhD guiding, and I'm going to not do the update, and we're going to try to see if I can remember how to do this. Connect equipment. We're going to connect the ASCOM camera. Initializing. Show preview. Exposing. Rats. I don't have the lens cap off. Bummer, huh? I just don't guide very often, so I've got the lens cap on the guiding camera. So let's keep trying this without guiding for now, rather than run out there and take the lens cap off. Let's open up our info pane about this NGC 4631, which is known as Caldwell 32. So we'll go over to SharpCap and we'll put in here Caldwell 32. And we're going to drop back to 100%. And since we meridian flipped again, let's do another plate solve. And we'll see how we did across the meridian. Oh, wait. You know what? I don't think we slewed here yet, did we? 4631. Oh, yeah, we did. No, we didn't. Did we? I've forgotten. It says we're 0.48 degrees off, so maybe we did slew here. So I guess it's correcting and corrected. Well, if we're already slewed there, why is it saying we could slew to it? Tiny, tiny bit of correction there. Okay, now I think we're on it. Let's plate solve one more time just to make sure, since I couldn't remember whether or not we had plate solved. Let's see if we can find NGC 4631 again, which is Caldwell 32. And next time, Jeff, I'll remember to take off the lens cap. You know what we've done? I've ordered some Gore-Tex fabric, and it just came in. I'm going to use this Gore-Tex. I'm going to design a scope cover just to have on the inside of the observatory to keep the dust off. And I think once I put that scope cover on, I don't think I'll even put the lens cap back on the guide camera anymore, because it's a screw-on lens cap, a little bit more trouble, and I don't even know if I'll remember to take it off at night because we use it so seldom. But anyway, we'll have this Gore-Tex on, and we'll always gather it up at the bottom and kind of lens cap it. Did it plate solve? Capturing a frame to plate solve, because I don't remember it saying. And so the way this Gore-Tex will work, hopefully, is that if it ever does spring a leak inside the observatory, the water would just run off of this Gore-Tex fabric. Oh yeah, we're exactly 0.00 degrees, so we're good to go on C32. Let's go down to our title and put here C32, which is a NGC 4631, a spiral galaxy. And go back up to the screen, and we'll see if we can find the spiral galaxy. And while we're starting to stack it there, let's read a little bit about it here. NGC 4631 is a barred spiral galaxy in Canes Venatici, located 25 million light years from the sun. This edge-on galaxy appears as a large, bright, thin streak in a telescope. This galaxy is the scene of active star formation. This reminds me of one of the Messier objects a little bit. It sort of looks like a bit of a whale, a sharp-pointed whale. Remember that Messier object? Nice. Does have star formation. Let's go back over here and let's do a color balance. and move our dark line at that crest. Then let's move our mids in, and you can already see a hint of this spiral galaxy in the middle. We'll zoom in now. Oh wow, this image looks beautiful. Look, it looks just exactly like it did in Starry Night Pro, doesn't it? Well, maybe not exactly, but look how we're starting to see the places where you can see dust blocking our way and all the soot that the arms have thrown out to the edges, and yet we can still make out star-forming regions. So I'm going to hurry up and grab an image of that while we can before some cloud comes by and confuses. Now this is 188%. That tells you again how small this is. Looks like there might be a satellite galaxy there. In our planetarium software, let's see if we can find out if there's another galaxy right here. Let's go back. Yep, sure enough, it's NGC 4627. I love it when our live view shows us something that we kind of discovered, and I'll put that in quotation marks. Obviously, we didn't discover NGC 4627, but if nobody else had already cataloged it, we would have known it was there by the light through our own telescope, real time, and you were here with us when we discovered the galaxy that has actually been discovered before, NGC 4627. We could see that it was a galaxy, a companion galaxy, right alongside this Caldwell object, which is Caldwell 32. Oh, a cloud came by. So I'm so glad we captured that image a while ago, because now once again, SharpCap will fail to be able to line up these frames very well. So I might as well stop, because really it doesn't do that much good. But we got to see the object anyway, and I like it that that happened fairly quickly. Now this we observed on March 27th last year. First target after learning first lessons on autofocus with APT, Astrophoto Tools, and also Nina. And I was comparing the two autofocus routines on this night. And this was the first target we ever looked at after we autofocused. And man, we loved that autofocus once we learned how to do that. So let's add an observation. Let's say extremely bothersome clouds kept modeling our tracking ability. But we still managed to capture an image before clouds threw us off track. We could see the dust lanes modeled along the edge, as well as star-forming regions. What's more, we, quote, discovered another companion galaxy, only to find out someone else had already cataloged it and beaten us to it. NGC 4627. Okay, now we're going to close that observation, but I want to do something else real quick. Let's go over here to NGC 4627. Select Other, NGC 4627. Isn't that cool that Starry Night Pro lets you do that? And let's do an observation of 4627. Notice we don't have to leave our observing list in order to do this. I'm going to put the observation here. We were watching Caldwell 32, but noticed this companion. Okay, and we actually observed this on April 30th, 2021. We love this. It honestly did look like a herring and a whale, but the hockey stick is a stretch. We could see the dust lanes, the star-forming regions, and the modeling effect, and the companion galaxy. Oh my goodness, is this the famous herring and the whale? We got to go read about this real quick. In the description, it doesn't say anything about a herring and a whale. So this companion is an elliptical. 4631 description. It doesn't say the herring and the whale. Let's go back over to let's go to C32 wiki. Oh, look, it's looking up Mercedes-Benz C-Class W203 and the C32 highway in Spain. Oh my goodness, we're going to have to put in the NGC number. NGC 4631 wiki. Here we go. Also known as the Whale Galaxy or Caldwell 32. You remember a while ago when we first saw this and I said, this reminds me of the other object is in the Messier list called the Whale Galaxy. It is the Whale Galaxy. And the little companion galaxy is like the little, whatever that is that normally travels with a whale, you know. I'm sorry. But I think it's funny that we didn't realize that we were describing the thing that we remembered that it almost looked like. So anyway, it's also known as peculiar. It was in the Atlas of Peculiar Galaxies, an example of a double galaxy or a galaxy pair. I'm going to go back to our observation. 4631. And I'm going to say oh, wow. This is crazy. It's not letting us add to it. Oh, here we go. Okay, so I put that sentence in about, it's also in the Atlas of Peculiar Galaxies as a double galaxy or a galaxy pair. I think that's interesting. That's fascinating. Okay, so there we go. The Whale Galaxy and the herring. Ready for the next object. We're going to add this to the Caldwell observed, and that's 4631. So we're going to go back to the live sky, search for 4631, and delete it. And then save. All right, our next object is, we've got 27 minutes left. Our next object is NGC 4559. So we'll center on that. Let's mark it. And we'll also slew to it. So it looks like we're in Coma Berenices in this case. Some people say Coma Berenices. How do you say it? Coma Berenices. And looks like our scope is settling down there. So we'll go back to the screen. And let's zoom in and see what we're looking at. Oh, this is a nice object. This is 4559. We're going to show the info on it. It is a spiral galaxy. And we did observe it, but we didn't say anything about it. We just observed it. A quick observation on March 27th, 2021. So we're going to do a new entry tonight and say foggy, misty, humid, humidity, let's see, 99% humidity. Let's go see what we can find of this. This is Caldwell 36. So we're going to go back to SharpCap and say C36. Let's go back out to auto. And we already slewed there. So let's plate solve just to make sure we're in the right ballpark. Plate solving, remember, it takes a picture of the sky and compares it to a database of stars. And then using that database, it figures out what adjustment would have to be made to the scope so it could line up the view through the scope exactly with the expected view. And we were only 1/100th of a degree off. So we got a pretty good model going. But you can see on this image, nevertheless, the way that it does move it some. Let's look at our sky view for a second. Oh, this is looking better and better. Except we've still got, can you tell, just a general humidity thing going on there. Just a general mist. But the clouds are gone at least. So the seeing should continue to improve as we go forward. So we got C36 there. Let's go down in our title and put C36 here. It's NGC 4559. And it is a spiral galaxy. Okay, so I think we're ready to go back to the screen. And now let's go to our sequence for start imaging. It'll change the exposure, the gain, clear the live stack, and start live stacking. Welcome, by the way, to this live stream from Emerald Hill Skies. If you tuned in late, we have several new folks on the stream now. We are located on the outskirts of Louisville, Kentucky, at an observatory that looks like this if we had it at night. These are daytime shots, just so you can see it. It's on an adjustable height pier. So we've raised it up so that it peeks out above the top of the Pier Tech Telestation 2 roll-off roof observatory. And this is outskirts of Louisville. We're in about Bortle 5 and it borders on Bortle 6 skies. It's a neat little 61-acre campus, and right there in the middle of it on this top ridge is this observatory. You can see the little 32-inch monitor we have to work from when we're in the observatory working on the scope. There you can get a nice view of the raised pier. Let's go over to the screen and let's see if we can tune this thing up a little bit. We can already see the spiral in the middle. Let's go to 100%. These objects are all fairly small, aren't they? Let's do a color balance one more time. And then let's tune this dark control to compromise so that we don't see a lot of that color blotching, but we still see as much of the object as we can. This is a beautiful little spiral. And I think we're going to see a little bit of arm materials if our seeing holds out here. Let's try to improve the contrast a little bit. Yeah. There we go. And then pump up the mids just a little. Papa Tech, welcome. Glad you're here. Oh, is the volume low? I probably am moving my mouth to the side of the microphone a lot. And I bet the reason I'm doing that is I'm looking past the mic sometimes to look into the phone. But see, you were kind enough to shoot straight with us and tell us that. I can also turn up the mic a little bit if that would be better. So there, I've turned it up a little bit. Look at those spiral arms. Is that better, Papa Tech? Is that better audio? By the way, we've been battling clouds, Papa Tech. Let's go over and read a little bit about this object while we're here. NGC 4459 is a lenticular galaxy in Coma Berenices, 55 million light years from the sun. It's a large, bright object in the telescope. This galaxy is a member of the M87 group, and it has a large black hole at its center. You know, black holes are kind of, oh, thanks, Papa Tech, for shooting straight with us. Black holes remind me of a drain in the middle of did you ever go to maybe an Outback restaurant or a kind of a cowboy kind of grill, and you walk into the restroom, and in the sink they have a thing that looks like a stick with me here, I'm going to make sense in a minute. They have a thing that looks like a trough that's just a metal flat bottom of the sink, but it's actually not flat. It's got a kind of a bowl shape to it, and as you let the water come into that trough, the water rotates around and begins going into that middle hole. Well, that's what we've got in the middle of this galaxy, which was just compromised by clouds. We've got a big, like a massive black hole in the middle of it. Rats, I hated that those clouds came. But I'm going to give you my word. Next time I'm going to be ready to do tracking, and we're going to see if tracking helps us with this. To see if with tracking, maybe we can still get by and not see this quite as much mottling going on. Anyway, let's go look at the Hubble view of this object. This is Caldwell 36. So we're going to go here and we're going to go back and then down the page to Caldwell 36. Did I say Hubble 36? Okay, so this is that one camera that has the different size resolution, and we're always going to see that corner in a Hubble image. This beautiful Hubble image captures the core and some of the spiral arms of the galaxy Caldwell 36, also known as NGC 4559. This spiral galaxy is located roughly 30 million light years from Earth in the constellation Coma Berenices. Supposed to be clear this entire weekend. 7 days too late. Yeah, you were all clouded out for the Messier marathon, Papa Tech. Apparent magnitude of 10. It can be spotted with a medium-sized scope. It's relatively easy to locate in the night sky because of its proximity to the Coma star cluster, which is known as Malat 111. Caldwell 36 happens to be discovered by, see if you can guess, William Herschel in 1785. And it's easiest to spot from the northern hemisphere in the spring. By the way, did you know this? The Hubble telescope is a monoscope and camera set. So to make color images like this one, they have to use filters. So they image it in red and then, green and then blue and so forth. They imaged it in both visible and infrared wavelengths in this case, using the wide field and the planetary camera 2. And then they stitched all these images together and stacked them all together. By the way, in 2016, astronomers observed a supernova-like outburst from one of the blue variables in this spiral galaxy, and they named it an LBV, a luminous blue variable. They're massive supergiant stars that show random variations in brightness and spectra. They are rare and currently only around 20 stars in all the known universe that we can observe with this classification. And one of them is right here in Caldwell 36. I'm just going to grab that text if they don't mind. I hope this is not copyrighted. They brighten significantly and lose mass, causing eruptions. Wow, that's pretty interesting. So, back to our observation of Caldwell 36. We could quickly begin seeing the spiral structure, even though seeing was troubled. We read that in this galaxy, there you go. That's 4559, Caldwell 36. And these are clouds. But there you see this spiral-armed, deformed galaxy being messed up by passing clouds. You know, you lose so much of the live stacking's advantages when you get this movement, because no longer can SharpCap compensate for, no longer can SharpCap stack and get rid of the noise in the image. Jeff is supposed to have clear tomorrow night, but you got to be in on some surgical suite. Sorry about that, man. Rats. So sorry. That's 4559. So we're going to add it to the observed list. Add it to the Caldwell observed. Then we're going to go over here to the live sky and search for 4559 and delete it from the working copy. And then we're going to save. And then we're going to come back to planetarium software. It's 12:17. We've got time to do this object, which is NGC 45. Whoops. Let's do another stack here. We lost our... I'm going to search for that again. We just finished 4559, didn't we? Lists. So that's the regular Caldwell list, and I need to refresh this somehow because we lost our... Let's search for something else first, like Polaris, and then let's go back and search for lists because we need to refresh that. Caldwell working. There we go. We did 4559. Where did 4559 go? Here it is. Okay, so we already erased it, but now we can sort again. And 4565A and 4565A. Jeff, thanks for being here. Sounds like you're on the surgical suite tomorrow, so you better sleep some. If I'm going to be on the operating table and you've done astronomy the night before, I'm going to be worried, just so you know. Glad you went to sleep. 4565A, spiral galaxy. So So there's 4565. But we're going to look at A. Why don't we just look at 4565? Why would we not do that? Is it not in the Caldwell list? It is. It's C38. 4565A is, that's odd. It's not even in the Caldwell list. 4565A. Let's remove this. Oh, we can't do it from StarNet Pro. That's another thing I've asked him to do, is let us remove things from that side panel, but the command is not there. 4565. So let's remove it here. This is the A version, and save. Now let's go find NGC 4565. Oh, look, there's A. We want to go to this one and add this to the Caldwell list, the Caldwell working list, and while we're at it, we'll add it to the Caldwell observed. Now we can search for, well, we might as well just open the info panel to it while we're here. $45.65. Why doesn't it show? Why doesn't it show the Caldwell number there? Did I just mess up? Oh, no, I think I messed up. Here's 4565A. Show info. Nope, it's not in the Caldwell catalog. 4565. Show info. Caldwell 38. Here we go. Yeah, sorry. I was just getting all confused there. So this is Caldwell 38, and it is a spiral galaxy. Let's go here and change this to Caldwell 38. Let's go down here to title. Change this to Caldwell 38. NGC 4565. Not 4565A. And let's go to auto. Let's go to start imaging, and it will, how is Bullwinkle doing? And of course, your fiber cables. That's awesome. Papa Tech remembers that a weekend or two ago, we were kind of in the middle of setting up the observatory. We had run the fiber from the observatory into the data center of the building, but we hadn't run it from the data closet to my office yet. So when we got ready to observe, I had to manually run a 200-foot patch fiber optic cable from the data closet switchboard where the fiber optic had come into our building to this, my office. That was on Saturday night. It was Friday night. It was so fun, and Saturday night was supposed to be clear. I just left it in the building and went home and slept. Came back Sunday afternoon and worked in the observatory. Came in Saturday night, and was unable to get a signal. And I started retracing the cable, and our robotic vacuum cleaner, which our staff has affectionately renamed Rocky on the upstairs level and Bullwinkle on the downstairs level. And the robotic vacuum on the downstairs level, Bullwinkle, had completely eaten up and digested the fiber optic cable. I mean, 20 yards of it. It was completely ruined. So we had to actually order a new cable, and while we were at it, I convinced our kind-hearted data IT guy here to help me run the cable properly. So we ran it, snaked it up through the ceiling tiles and up through the wall, and so now it's coming out here on the wall beside me. Happy to tell you. So, Papa Tech, to answer your question, Bullwinkle is fine, and also the fiber optic cable is fine. I'm going to catch an image of this because you can already tell. Look at the way the clouds have already thrown off our tracking again. But there you can already see this beautiful edge-on spiral galaxy, even though it's going to be messed up because these clouds keep messing up our seeing in SharpCap. But how pretty is that? Even though it's messed up and a messed up image, it's still beautiful, isn't it? That's just 2 minutes. Let's clear and let that percolate again. And while it's doing it, let's go over to the Hubble version. Can't see only your face. Thank you so much, Papa Tech. I forget sometimes to put it back on the screen. Let's go over here to the Hubble version. And let's go back and look up Caldwell 38, which is this beautiful edge-on galaxy. Look at that. Isn't that an amazing picture? Nicknamed the Needle Galaxy because in most telescopes it looks thin and sharp as a pin. It is a spiral galaxy, but because it is seen almost perfectly edge-on, the spiral structure is concealed. And here's a piece of it. There's the far-off image of it. Let's go back over to here and we'll grab it real quick. Look at that. Isn't it beautiful? Wow. It looks like a flying saucer. This is a galactic wanderer. It's a flying saucer. Wow, it's beautiful. Thank you, Lord, for making these objects so amazing. Well, this is probably a good place to stop. We have finished up our 2 hours here in 3 minutes. I just want to ask, if you have not already done so, if you enjoy content like this, we would love it if you would click subscribe. And I'll tell you what that does when you maybe click thumbs up and subscribe. It elevates the channel in other people's streams, other people's pick lists in YouTube. And the great thing is it doesn't cost you anything. Now, if you really like this content, you could also click the bell, and that way you would be notified when we were releasing videos like this one. It does a great favor to us, and it doesn't cost you anything on your end, but it really does help the channel. And we are so sorry that tonight, in spite of our best efforts, in spite of the crystal clear forecast that we had received, we instead were confronted with these occasional mist clouds, like the ones that you're seeing come across our image. These misty clouds that wander across and not only model the image a bit, but also mess up our seeing. But this particular object, which I don't think we've ever observed before, NGC 4565, Caldwell 38, first time observing this object, sometimes called the needle. Or is that what it called it? The needle, or was it the silver needle? The Needle Galaxy, sometimes called the Needle Galaxy. Unfortunately, clouds handicapped our seeing, but we were still captivated just by what we could see. Perfectly edge on spiral. So we'll close that observation, and also with it we'll close our live stream for tonight. But man, thank you for spending this time with us. There's a lot of other content on this channel. If you're interested in this kind of thing, I think we have, wow, 100 and some videos. You're welcome to kind of scan through them, scrub through them. We just did the Messier Marathon last weekend. You can scrub through don't watch it all because it's 25 hours, I think, 3 parts. But there's a lot of content on this stream, and we'd like to invite you to come back and see it. Also, whenever we observe, we'll always do an announcement in cloudy nights, but also you can go to the website Emerald Hill Skies and sign on to an email list. And we use that email list exclusively to send you an email the night before we're going to observe. And sure enough, we did that last night. Sometimes we even go 2 nights before we observe. So you'll get an email the night before. Plus, if you're on YouTube and you hit the bell, you'll be notified when we're live streaming. But if you don't have to be looking at your phone, that's a little bit harder. So it's really handy if you go to emeraldhillskies.com and sign up. So I'll look forward to seeing you next time around. We are so grateful that you stopped, and of course we're most of all grateful to God who made all these cool objects like this flying saucer galaxy, the needle that we've been observing right now. I'll just look and see. Michael C., by the way, is going to attempt his first live stream via Zoom in 3.5 hours. So Eastern time, that's going to be around 4 a.m. here. But you can always go look at it afterward, I bet. Michael C. says lots of southern Caldwell objects. Man, that's great, Michael. We'll have to refer folks to yours. If you can go to the ones that are, you know, the things that we can only see down there where you are, we'd love to look at those. We'll look forward to it. Good night, all. God bless, and we'll look forward to seeing you next time. Thanks again for spending this part of your evening with us. Take care, and good night.